Welcome to the deep dive. We take complex topics, boil them down for you.
Get right to the interesting stuff.
Exactly. And today, we're tackling a really fascinating, maybe even controversial one, the memory of water.
The idea that water, plain old H2O, can somehow hold on to information about substances it once contained.
Even after they're completely diluted away, it sounds, well, pretty out there.
It does, but it sparked genuine scientific debate, even reached, Nobel Circle.
Yeah, we saw that in the sources. So our mission today is to explore this. Where did it start? What are the arguments?
Both for and against, and what could it possibly mean if it were true? We've looked at the research, the history.
All right, let's dive in. Where does the story really begin?
Okay, so the big starting point, according to the material, was 1988. A paper in Nature.
Nature. Okay, that's a top journal.
Absolutely. It was by a French immunologist, Jacques Benveniste.
And what was he claiming?
He claimed his experiments showed water could essentially remember an antibody, specifically an anti-serum against IgE, even when it was diluted so much that statistically there shouldn't have been a single molecule of that antibody left.
Wow. So like dilutions beyond Avogadro's number.
Exactly. Way beyond.
Yeah.
Which, from standard chemistry perspective, shouldn't be possible.
And the immediate thought, I guess, was homeopathy.
That was the huge implication, yeah. Our sources point this out clearly. Suddenly, there seemed to be a potential scientific basis for how homeopathic remedies, which are often diluted to nothingness, might work.
Okay, so major claim in a major journal. What happened next? Chaos.
Pretty much. Intense skepticism from the scientific community, as you expect.
Why?
And Nature itself, the journal that published it, took the unusual step of sending an investigation team to Benveniste's lab.
They sent investigators.
Yes. And get this, the team included James Randi.
The magician. James Randi, the skeptic.
The very same. They wanted to ensure there was no subtle trickery or error involved.
That's incredible. A magician investigating a scientific claim in Nature.
It tells you how extraordinary the claim was perceived to be.
So what did Randi and the team find?
Well, the sources are clear on this. They couldn't replicate Benveniste's results under controlled, blinded conditions.
Ah, the classic replication problem.
Exactly. And that led to the paper being, well, largely discredited. Benveniste himself was quite ostracized by the scientific community afterward.
So a pretty dramatic rise and fall for that initial idea.
A very dramatic cautionary tale in science, you could say.
Okay, so Benveniste's specific claim didn't hold up to scrutiny. But did the idea of water memory just die then?
Not entirely. The research we looked at shows it kind of morphed. People started exploring other, maybe more subtle possibilities.
How so? What are the modern ideas?
Well, the sources outline sort of three main threads, though. Importantly, none are really accepted by mainstream science yet.
Okay, good caveat. What's the first one?
It involves hydrogen bond networks. We know water molecules are constantly forming and breaking these hydrogen bonds, right?
Yeah, that's basic water chemistry. They're very fleeting connections, picoseconds, isn't it?
Usually, yes. Extremely short-lived. But the idea some researchers are exploring is whether, under certain conditions, maybe more stable, longer-lasting structures could form. Supramolecular assemblies, they sometimes call them.
Like water molecules forming more persistent patterns.
Kind of. The thought is maybe these patterns could somehow hold an imprint, a memory, of a substance that used to be there.
Still sounds like a stretch against standard understanding, but okay. What's the second idea?
This one gets into quantum physics, quantum coherence hypothesis.
Quantum coherence.
Yeah.
Water.
Yeah. Particularly the work of a physicist named Emilio del Giudice. He proposed something called coherent domains.
Coherent domains, what are those essentially?
The idea is regions within water where the molecules aren't just randomly jiggling, but their quantum vibrations become synchronized, like they're acting together.
Okay.
And Del Giudice theorized these domains could store and maybe even transmit electromagnetic information. Our sources mentioned his 1988 paper on this.
So water acting like a quantum information medium?
That's sort of the implication, yeah. Very different from the simple solvent picture.
Definitely different. And the third direction, you said there were three.
Right. The third is perhaps even more unconventional, electromagnetic imprinting.
Okay. Intriguing name. What's that about?
This involves claims that you don't even need the original substance, just its electromagnetic signature.
Wait, how?
The idea, as described in the sources, is that water could be informed or structured by specific electromagnetic fields, or even, get this, by digital signals representing a compound.
Digital signals changing water properties? Without any molecules.
That's the claim. Highly controversial, as you can imagine.
I can absolutely imagine. So these are the avenues being explored, but you mentioned mainstream skepticism.
Oh, absolutely. It's crucial to restate that. The overwhelming scientific consensus is still very much against the idea of water memory in any of these forms.
Why? What are the main criticisms?
Well, the biggest one is still the lack of reproducible evidence. Consistently, when independent labs try to rigorously test these claims, the effects don't show up.
Right, the replication issue again.
Exactly. Critics argue that the positive results sometimes reported are likely experimental artifacts.
Meaning errors or noise, things that look like a signal but aren't.
Precisely. Or subtle biases in how experiments are run or interpreted. Plus, there's the fundamental problem. There's just no widely accepted physical mechanism for how water could hold this kind of long-term memory.
It seems to violate basic principles.
Principles of statistical mechanics, thermodynamics, chemistry.
Hmm?
Yeah. At those dilutions, any effect of the original solute should just be averaged out, lost in the random motion of water molecules.
Makes sense. But what do the proponents say back? How do they counter these criticisms?
They have arguments, of course. Some suggest the failures to replicate are because the effect is incredibly sensitive.
Sensitive to what?
To subtle environmental factors, maybe electromagnetic fields, maybe even the experimenter's intention. Some propose things not usually controlled for.
Okay. That makes experiments very difficult then.
Extremely. Others argue we might need new kinds of instruments, maybe operating at the quantum level, to actually detect these subtle structures or effects.
So current tech might be too crude.
That's the argument some make. And this brings us to another really fascinating and, again, controversial piece of the puzzle. Luc Montagnier.
Ah, the Nobel laureate. He won for HIV research, right?
That's him. But later in his career, in 2010, our sources highlight, he published research claiming something quite radical related to water memory.
What did he claim?
He suggests that highly diluted solutions of DNA could emit specific low-frequency electromagnetic signals.
Okay, electromagnetic signals from diluted DNA.
And not only that, he claimed these signals could be recorded, transmitted digitally, and then used to imprint information onto pure water.
Imprint DNA information onto water using electromagnetic signals.
Yes, and that this informed water could then somehow be used in a PCR reaction to reconstruct the original DNA sequence.
Whoa, that is a huge claim, especially from a Nobel laureate.
Exactly. It caused an enormous stir, a lot of fascination, but also immense skepticism and criticism from the scientific community. It threw fuel back onto the water memory fire, but in this new electromagnetic context.
Right. So putting aside the controversy for a second, if any of this were proven true water memory, EM imprinting, what would the applications even look like? The sources mention some potential impacts.
Well, the potential implications are huge, almost revolutionary, if it held up.
Like what?
Well, in medicine, you can imagine ultra-low dose therapies. Maybe treatments based on information rather than just molecules.
Less reliance on high-dose drugs, maybe?
Perhaps. The sources also speculate about breakthroughs in, say, quantum computing or new forms of energy transfer.
Using water structure.
Potentially. There's even mention of entanglement-based water structuring for information systems.
Okay, that sounds like pure science fiction.
It does lean that way, doesn't it? But it shows the scale of thinking if the premise were true. However,
There's always a however.
the sources are very clear. These applications are purely hypothetical right now because we lack that clear, proven mechanism. The how is missing.
So all the structured water or energized water products you sometimes see advertised.
The evidence for their effectiveness, as the research points out, is generally anecdotal or based on poorly controlled studies. There's no solid scientific backing accepted by the mainstream yet.
But science doesn't stand still. Is there any new technology that might help settle this debate?
There might be. The material we reviewed mentions things like terahertz spectroscopy and ultra-fast femtosecond lasers.
Fancy tools. How could they help?
These techniques can probe the really fast movements and interactions of water molecules down to quadrillionths of a second.
So they could potentially see these fleeting structures, or maybe even longer-lived ones if they exist.
That's the hope. They might give us a much clearer picture of water's dynamics and whether any kind of persistent information storage is remotely possible.
Okay, so the experimental side is ongoing, but the sources also took this into a more philosophical direction, didn't they?
They did. It really pushes you to think differently if you entertain the possibility, even hypothetically.
What kind of philosophical shifts?
Well, think about it. If water can hold information, Does that mean information can exist separately from matter in some way?
Hmm. Information is a more fundamental thing.
Maybe. Or could biological systems be responding not just to molecules hitting receptors, but to fields, to resonance, to information carried by water?
Like our bodies are sensitive to more subtle things than just chemistry.
That's the implication. It could change how we think about healing, about memory itself.
Yeah.
Maybe they have a wave-based aspect, not just chemical.
That's a pretty profound shift.
It is. It reframes water from just being a background solvent to potentially being an active medium, a medium of resonance, a biological field carrier, as the sources put it.
A bridge between life and the environment.
Yeah, and it even touches on quantum ideas, coherence, observation affecting reality. It really broadens the questions.
So after all this, where does it leave us? What's the takeaway for someone listening?
I think it leaves us with this big, unresolved question hanging in the air. Can water really remember?
Is there something truly mysterious about this everyday substance that we've missed? Could it connect to things like the placebo effect or other unexplained phenomena?
Or is the conventional view correct? Is it all just wishful thinking, experimental error, maybe confirmation bias driving these fringe ideas?
The data so far seems to lean towards the skeptical view, but the questions persist.
They definitely do. It's a fascinating area where known physics meets very speculative ideas.
Definitely something to mull over. And as our sources reminded us near the end, your brain itself is about 73% water.
Makes you think, doesn't it?
It certainly does. Keep these intriguing ideas flowing.